Have you ever wondered how the Inuit managed to live in igloos made of ice in the heart of the Arctic? Let me first lay down the scientific foundation in a simple way, as we always do. Heat is a form of energy. When a material gains energy, its molecules start vibrating in place, transferring these vibrations to neighboring molecules, depending on the amount of energy causing the initial vibration. This thermal energy transfers from one material to another based on the difference in temperature between them. Coldness, on the other hand, is simply the loss of heat. There's no such thing as coldness. It's just a term we use to describe the absence of heat. Heat always transfers from a warmer object to a cooler one until both reach the same temperature, a state known as thermal equilibrium. How does heat transfer between objects? There are three main ways. 1. Conduction. Heat transfers through direct contact between materials, as molecules vibrate and pass energy to their neighbors. 2. Convection. This occurs in liquids and gases. When a gas heats up, its density decreases, causing it to rise, while cooler gas sinks to take its place. For example, when you boil water, steam rises. 3. Radiation. Heat transfer through electromagnetic waves, such as the sun's heat reaching us through the vacuum of space. Got it. Now let's connect this to how igloos work. How does an icehouse keep people warm, surrounded by tons of ice? The secret lies in what we just explained and in the unique properties of the ice used in building igloos. Here's how. When you sit inside an igloo, your body emits heat naturally via radiation. This heat warms the air around you, which rises, convection, and cooler air moves down to replace it. Meanwhile, the warm air escapes through the walls, conduction. But there's more. The magic lies in the type of ice used. The Inuit, specifically the Inuit tribes, have over 50 words in their language to describe snow, reflecting its various types and uses. The snow they use for igloos contains about 95% air trapped between its particles, making it an excellent insulator. These air pockets prevent heat from escaping and block the cold outside from penetrating inside. When constructing an igloo, they cut blocks of compact snow, not solid ice, which is denser and less insulating. These blocks are stacked in a shape resembling an elliptical dome rather than a perfect half-sphere. This design, known as a catenary, like the curve a rope makes when held at both ends, is structurally efficient, evenly distributing weight. Inside, the igloo's floor is tiered. The entrance is a low, narrow tunnel that keeps cold air at bay. The living area is elevated to trap warm air rising from the fire or human body heat, creating a temperature difference of up to 60 degrees Celsius. Outside, it might be minus 45 degrees Celsius, but inside, it can reach 16 degrees Celsius. What about the fire inside? Doesn't it melt the ice? The fire pit is carefully positioned, away from the walls. While the inner surface of the ice may melt slightly, the extreme cold outside quickly refreezes it, forming a thin insulating layer. Additionally, a ventilation hole prevents smoke buildup while maintaining stable warmth inside. Interestingly, humans aren't the first to discover this snow-insulating phenomenon. For thousands of years, animals like polar bears have instinctively used similar techniques, burrowing into snow for protection against harsh Arctic conditions. Finally, you might wonder why the igloo's entrance is so small. It's designed this way to trap warm air inside, prevent animals from entering, and deter predators like polar bears. The shape of the igloo, resembling a reclining polar bear, also psychologically scares off wildlife, associating it with human danger. I hope this explanation was clear and helpful. If you ever find yourself in icy wilderness, you'll know how to survive. Even if you can't build a perfect igloo, you'll at least understand how to dig a protective snow shelter. Now, you know something not everyone does.